Alrighty, so we've been working on definite integrals, meaning that we have numbers for our limits of integration, right? And so when we look at G, do you think that this is a U substitution kind of situation? Okay. And I think a good way to look at this is to kind of assume that it is and see if you can find a U, and if like none of your U's work, then maybe it isn't, you need to go down the other road, something like that, whatever works the best for you. But what do you think that we would want to choose for U? The 1/3 part? Okay, good. So we'll say that U, oh, well, no, not like that. We'll say that U is equal to, we're going to do the inside of the cosine here, 1/3 x cubed minus 2x squared minus 12x plus 1. Okay? So then we'll take the derivative, du equals, so that's going to be x squared minus 4x minus 12, and then don't forget your dx there. Now, is that good news or bad news? Looks like good news, right? Because it matches this right here, and we'll go with our dx. Were you not here yesterday? Oh. Well, all right, hang on just a second. Oh, here it is. Thought I'd given them all out. That's why I was. Okay. So are we all good at that point then? So what else do I need to do before I start substituting things in? Like let's go ahead and, I'm going to say the integral, am I going to go from -3 to 7? No. Okay, so I need to figure out what that's going to be. So if x is equal to -3, then I have to figure out what u is, right? So I'm going to have to substitute it in there. So u would be equal to 1/3 times -3 cubed is going to be -27, right? Minus 2 times 9, which is 18, plus 36, plus 1. Do y'all agree with that? You got to keep up with me because I'm for real. Not had a lot of sleep here. So 1/3 of -27 is -9, right? -18 and a positive 36 is going to be a positive 18. Plus 1, that's going to be a positive 19. So I think we're going with 10 here. Do you agree with that? Okay. So then we'll do the other u. If x is equal to 7, all right, so then u is equal to 1/3. Oh, this is gross. What is 7 cubed? Plus 7 times 49. I think it's 243. 343. Okay. There's a 43 in there. That's all I could do. 343. Okay. Times 343. All right, so I'm putting 7 in here. Minus 98, I believe. Yeah. Then 7 times 12, that's going to be minus 84. And then plus 1. I don't know why this is so yucky. I'm going to do this question. Okay. So negative 98 and a negative 84, that's going to be a negative 182. Yes. Okay. And then plus 1, it's a negative 181. Yes? Okay, so this is equal to 343 over 3 minus 181. That's what we decided. Okay. Can we cancel the 3's out? No, we can't. All right, so then I need to get a common denominator. Yes? I have a feeling, this question is not on my other thing. I think it shouldn't be this yucky, but it's okay. We'll make it through it. But y'all agree that I haven't made a mistake yet, right? Yet. Notice I said yet. All right, so then I need to get a common denominator. So 181 times 3, 3, 4, 2, 543? Sure. Okay. Do you agree with my math? Okay. Well, it was 181 times 3. You can multiply it yourself. Then we're going 324, 3. No. Yeah, no, never mind. So it should have been 240. See, I should have, so it is 543. I'm going with 543. Equals 343 over 3 minus 543 over 3, which leaves me what? 200 over 3, which is not as ugly as it could be. Yes? Okie dokie. Whew. That's rough. Okay. So we've got, instead of negative 3, what do we put there? Oh, this should say U. That's why. 7. And instead of negative 203, what should I put? 10. Oh, that's what that was X. I'm sorry. I swear I heard somebody say 7, and I went with it. I'm sorry. I'm sure you didn't. It's 10, and this would be negative 200 over 3. All right, so now when we do our, see, this is just a gross problem altogether, but that's okay because you're going to see why it's totally fine that it's gross, because we are substituting in. So this stuff is du, right? So this is going to give me the cosine of u du, right? So when we integrate cosine, what do we get? Sine. So this is going to be the sine of u plus c evaluated from 10 to negative 200 over 3. Yes? So we do, bless you, the first one here, sine of negative 200 over 3 minus the sine of 10. Do you know either one of those? Nope. You leave it. You're done. That's all you can do. Okay. On the AP exam, you shouldn't have to get this gross when you're finding these numbers. Sorry. This is one I did not work out ahead of time because it's different than the piece of paper that I have where I have everything worked out. So I don't foresee that happening there. All right, but you still should have some room for 2 more. Yes? Okay, so we're going to do 2 more here. So if we are given, so if the integral from negative 2 to 5 of f of x dx equals 4, we want to find the integral from negative 2 to 5 of 3 times f of x minus 2 dx. So they give us some information. This is what we want to find, okay? This is not going to be a u substitution type of thing because we have a function in here. We're going to use some properties of integrals to split this stuff up, okay? If I have an integral and I have 2 things being either added or subtracted, I can split that into 2 integrals. Would you agree with that? So I can say that this is going to be the integral from negative 2 to 5 of 3 times f of x dx minus the integral from negative 2 to 5 of 2 dx. Do you agree that that is the same thing? All I did was basically split it right here into two integrals. Everybody with me so far? Or do you see a mistake? Because now I'm... Well, I did minus, and then I put the integral right there. Does that make sense? Like I split it. I could do plus and negative there, but this is just minus that part. This is different than when we were substituting these in, if that's what's confusing you. We're not taking we're not evaluating at 5 and then subtracting the other one. This is not the fundamental theorem of calculus. I see where that is now. Okay. This is not the fundamental theorem of calculus. I'm just splitting using my integral rules. Okay. So had this been a positive sign, then this would be plus. So it has to do with this sign right here, not the fact that I'm splitting it up. Okay. Does that make sense now? I see where the hesitation was there. Okay. So yeah, so this is minus. Then I can do one more thing because I can bring this 3 out in front, right? So I can say 3 times the integral of negative 2 to 5 of f of x dx minus the integral from negative 2 to 5 of 2 dx. And now we don't always, not always making you split them. So let me look at like this one over here that you can kind of see, but the writing's kind of small. So, oops. So we have this, and then they sort of split it up. There's some things missing here that we want to make sure we have. We would totally need a dx here on all of these, or you would get absolutely no points, whoever was writing this. Let's just point that out. But you have this, and then you can integrate it as it is. You don't have to split it into other ones, but it looks like they basically attempted to, but then again left all the little dx's that are important there. But that's what we're doing here. We're basically taking this and splitting it into 5 of them. Okay, and we don't always write it like that necessarily to do it, but here it's going to help us to write it. All right, does that help? So we're just using one of those properties that sometimes we can kind of overlook. All right, so now I don't have to do anything totally crazy, right? Because I know what this is. They gave me that right here, right? This part is equal to 4. So I have this 3 times this right here, they tell me is 4, right? Minus, when I want to integrate a definite integral. Now, I know if I integrate 2, I get 2x, right? And then I can go through all of that. But remember what this means. This is just 2 times the change in x. What is your change in x here? 7. 5 minus a negative 2 is 7, right? So this is really just minus 2 times 7, which is going to give you 12 minus 14, which is a negative 2. Okay? So I wanted you to see that just because we're integrating and we have limits of integration, we're not necessarily always doing a u. We're not necessarily always having to use the fundamental theorem. We have integral properties that we can use to split things up. Okay? We good with that? All right. Then hopefully you still have some room on here somehow. And we're going to do one more. We're going to do an piecewise because I know you don't really like those. And it would probably be helpful if we did another one together. F of x is equal to, all right, x plus 1 is less than or equal to 0. X squared plus 1, oh, not less than or equal to 0, Jesus Christ. Where x is less than or equal to 0, and x squared plus 1 when x is greater than 0. Okay. And we want to evaluate the integral from negative 3 to 2 of f of x dx. Okay. Everybody with me so far? Just got it written down. All right, so I want to go from negative 3 to 2. But really what I'm going to have to do is I'm going to have to go from negative 3 to 0 and then 0 to 2, right? Because it's stopping at 0. So that means that I want, when I actually do this, I'm going to have the integral from negative 3 to 2. Now, if I'm going to do that, not from 2 to 0, negative 3 to 0. Which function do I use from negative 3 to 0? The first or the second? First, because it's x is less than or equal to 0, right? Of x plus 1 dx, right? And then I'm going to add to that the integral from 0 to 2 of this one when it's greater than 0, x squared plus 1 dx. Don't forget your dx's and stuff like that because you will get nailed on the notation stuff. All right, we all good so far? Now, are these pretty easy things to integrate? Yes, not so bad. So when I integrate this first one here, when I integrate x, what do I get? X squared over 2, okay? Or 1/2 x squared, whatever you prefer to do. Plus, when I integrate 1, what do I get? X, okay? Do I really need to put the plus c? No, I'm okay. As long as I've got actual numbers, I don't have to. And I'm going to evaluate this from negative 3 to 0. Then I'm going to add to that this second one. When I integrate x squared, what do I get? X cubed over 3, good. Plus what? X, and I'm evaluating that from 0 to 2. Okay, so basically you're just kind of doing 2 in one problem, yes? So when I set that equal 2. All right, so then I'm going to do this part. So this part first. I'm going to evaluate at 0. So when I substitute in my 0, what do I get? 0 plus 0 is just 0, right? Okay. And then I'm going to do minus, and I evaluated at negative 3, right? Minus, when I substitute in the negative 3, I'm going to get 9 over 2, and then minus 3. Everybody okay with that? Then I'm going to do this part. So then I'm going to add to that. When I substitute in my 2, what's 2 cubed? 8. So I get 8 over 3 plus 2 minus, and then when I substitute in this 0, I'm going to basically get 0 right there. What's the question? Where'd the minus come from? This is from the fundamental theorem of calculus, what we were doing on all the rest of them. So what I have here is I did this part is right here, and then this part is right here. And I'm just adding them together because I'm basically doing 2 things in one. Right? We good with that? Okay. Free response, we can just leave it. But we want to be careful with our signs, right? If it's not free response, we have to be able to combine this stuff, so let's make sure that we can do this correctly. When I go to get a common denominator here, that would be 9/2 minus 6/2, right? What's 9/2 minus 6/2? 3/2, okay? Or you can do this, negative. We have 9/2 minus 6/2, and then plus 8/3 plus what there? 6/3, okay? So this will give me 9/2 minus 6/2 is 3/2, but that would be negative 3/2, right? Plus 14/3. Then I would need another common denominator, so I'd get negative 9/6 plus 28/6, which would give me 19/6. If this is free response, you absolutely don't do any of that stuff in purple. You stop right there, okay? But again, it could totally be a multiple choice, and you got to match it up, so we still need to practice those skills. Okay, are we good? Any questions? You ready to practice? The answer is yes. We love math, and this is lots of fun. And this one has the answers on the bottom as well. Okay? So practice time. And remember, you can retest on that last test if you want to. But you've got to see if that's 3.